All right. So I did record a lecture. I put an announcement. I think that gets sent to your email. Is that correct? Yes, no. Technically, by default,
I checked on Kansas for email.
by default it goes to your email, right? So there was a lecture that you guys were supposed to watch. I just did some current events in that. And then on Monday, I sent out so I'm calling it a lab now. It's a lab for this class. It's not like your lab. So it was something to do while I was gone. So I put the assignment up on, all right, so this is a different lab one than your lab, right? So this is for me, since I was gone, to give you something to do. So it's converting binary numbers. And of course, all my windows are messed up here. All right, so we talked about binary, right? There's a couple different ways. I will talk about bitwise OR here today, just a little bit, briefly. So that is one way to solve it, is to use bits, and we can test to see if something is true or not. The other way is to use the method that we have discussed in class, where you subtract, right? So if it's bigger than, say, 128, right? Then you subtract 128 and you mark that as a 1, right? So you should be able to test this. I put a couple different, so I'm going to try and include examples for labs and homeworks. Well, my labs. Maybe I should call them something else. In-class projects or something. That just doesn't roll off the tongue. But I'll give you inputs for you to test against. So for example, the number 67, we can see that, well, that's greater than 64, so we mark that as a 1. All right, so you can use a bunch of if statements to do this, or you could use bitwise OR, and I'll talk about that, or bitwise AND. I'll talk about that in a second. So, right, how many of you guys started on this? How many of you finished it? Okay, all right, I put the due date as Friday, so if you have questions, right, you can come in during my office hours or email me to ask if there's a different time that works, right? So I don't want you to not do it. You should have started on it on Monday, and if you didn't, well, you get a little bit of time to work on it. Are there any questions on this? Yes.
Should it be like a lot of if statements?
Well, not a lot, right? Like 8 of them.
So I did something definitely wrong, because there was like in the hundred.
Yeah, I used a lot of
You could do it with 8. You could do it with 8 if statements.
Like when I did it with 8, like it would do the 128, but then it would skip the rest of them if it didn't apply to.
Okay, so the problem you probably made was you probably did if else's.
Okay.
You could do it with 8 ifs, right? No else's on those, right? So if it's greater than 128, right, then you subtract 128 and you print off the statement where it's a 0.
Yeah.
Then you go on to the next one, right? So if you do them all else's, it will only execute 1. So yeah, you'd end up with a lot if you would do it that other way. So, hey, you learned something, right? You learned how to type.
Yeah.
Or copy paste a lot, right? And then type a little. Okay? Other questions? No? Okay. All right, so I'll talk about the bitwise OR here for just a second, and you can discuss that. So we've talked about how we take our numbers, right, and we can convert them from one type to another, right? So we talked about using hex, we talked about using decimal. So let me just create a byte here. See if it'll let me do this. I never remember the syntax for this. 1 second, let me do it. What is the, oh, A is 10, right? Right, so if we have the number 10, if we remember when we convert that to binary, right, that's 1, 0, 1, 0. Right, so as far as bits, we have 1, 0, 1, 0, right? So if I want to check to see if the second bit is set, well, okay, what is, this first bit is 2 to the what power? You spent it on 0? 2 to the 0, right? Or 1. This one is 2 to the 1, which is 2. 2 to the second, 4. Right? So if we want to check and see if one of these bits is set, we can use our logical operators. Right? So we have ands and ors. And the rules for the logical operators, I guess we should discuss those first. Where's my... We haven't discussed logical operators, have we? Was that in the chapter? We talked about logical and. I don't know if they talk about bitwise. Well, we'll talk about them anyway. All right, so we have a couple different operators that we can talk about. So we have one which is called AND. And so when we're doing bitwise AND, we have a couple rules. So bitwise AND means that both bits, we're going to be comparing two things. Both bits have to be 1. So let's write out our possible 0, 1, 0, 1. Okay, so these are all the different possible combinations of zeros and ones. And what an AND says is both of them have to be 1. Right? So both of these 1? No. Are both of these 1? Yes. Are both of these 1? No. Are both of these 1? No. Right? So these are all the 4 different possible combinations of bits that we could have. Right? So AND means that you only get a true if you have a 1 and a 1, right? And that gives you a 1. We also have OR. And OR means, is either one of them a 1? So we do the same set of possible combinations. Okay, is either one of them a 1? Yes. Is either one a 1? Yes. Is either one a 1? No. Yes. Okay? And then we got one more, which is called exclusive OR. Written as XOR or exclusive OR. And exclusive OR has a weird rule, which is, and I think of it this way, are they different? Okay? So let's give our same set of operations, 0, 1, 0, 1. So are they different? Are they different? Are they different? Are they different? Okay. So those are our 3 logical operators we have. We have one more, which I've already described when we talked about 2's complement, and that's called negation. And in negation, I use that as the flip all the bits, remember? So negation means you just take every 0 and it becomes a 1, every 1 becomes a 0. Right? So it's what's called a unary, or it operates on one thing. So if I have 0, 1, 0, 1, if I do it sometimes write it this way. In Java, you might write an exclamation point, right? So we just flip all the bits, right? So every 1 becomes a 0, every 0 becomes a 1. So these are our different operators. Now, when we have a number like 1010 and we want to see if it has a power 2 in it, well, we can use what's called a mask, or just pick out that number and say, do a AND on it, right? So if we pick the other number, let me do another page. So let's say our number is, and we want to check if the bit 2 is in there, or it's, right, 2 to the 1. Okay, so 2 to the 1 is equal to 2. So what we can do is we can do an AND with the number 2. Well, if I write the number 2 all out, right? And then if I do an AND, the only way I'm going to get any output in this is if the 2-bit is set in the first number, right? So my result, by doing an AND, I'd end up with the number, right? If I'm doing an AND, 1 and 1, that's true, right? If I would check for 2 to the 3, oh no, I don't want to do 3. 2 to the 4. So what's 2 to the 4? 16. So let me do my number again. One, 2, 4. Oh, oops. Oh no. 16. Right? 1, 2, 4, 8, 16. If I compare that to my original number, right, and I do an AND, what's my result going to be? If I go down the row and I say AND, well, in the second number, I only have 1 bit that's set. So the only way I can get an AND, a 1 out of that, is if that bit was in the first number. Is it in the first number? No. So I'll get a 0, right? Or all zeros. Hex 0, 0, right? So that's how we can do AND. So when we're trying to think about when we're printing off that number, well, we could use a logical AND and check each bit and see if it is set. So let's do an example of that. So let's check the bit 128. Why is it complaining on that? Okay, I'm making an int. So if we want to get the result of this, we can say now remember when we did a logical AND we used 2 ampersands, but when we do a bitwise AND we use 1 ampersand. Right? So that's how you can do a bitwise. So let's do B2. So this will check. Oh, come on. It's going to convert it to an int, of course. Stinking. And then it's going to complain. Oh, I got to do the whole thing. Parentheses for the win. And let's go ahead and print it out. Anybody remember the format we use for hex? X. Very good. I'll put a 0, 2. I want 2 X's. If I make it an uppercase, it'll make all the things uppercase. Well, let's actually do 3 of these. We'll print off all 3 numbers, right? and is, so I'll do BB2 result. And I'll put a new line here because otherwise it just looks weird. All right, so I had hex A and I had hex 80, right? So remember, we convert that into binary, right? We'd end up with the 80 would be a 1 followed by 7 zeros, right? A is 1010. Right, so we could pick any number we want to run this on. So let's say, well, if it's 216, and I have to convert it to a byte, of course. Right, so if you go and rewrite that, right, you end up with, well, D8 apparently is our number, right? You can convert that into binary and see that yes, indeed, the 128-bit is set. Right, so again, this is just another way that you could do it. And, right, it would also end up with a lot of if statements. So, again, if the bit is set, right, that result is going to be not 0. If it's not set, the result will be 0. Right, and so that's what you can do your if on. If it's 0, right, bit is set. If it's not, the bit is not set. So, if you were unimpressed by the hardness of the homework or the lab, right, go ahead and try and do it using your logical operators, and that will give you a little bit of a challenge. So, and if you want to do it, actually, I'll give you extra credit if you want to do it that way. So, for those of you who are looking for things like that. All right, any questions on that? Bitwise operators?
You said that the XOR compares if they're the same. Or was it if they're different?
Your question is, are they different?
That's what it does?
Mm-hmm. Are they
Is there
different?
one that do, yeah, are they the same? Can you reverse it?
So you could negate a XOR, right? So that's basically all the different, when we talk about all of these bitwise operators and or XOR negate, those are actually implemented as transistors on the circuit board. So those are our logical things where we actually take two signals, right, and we run them through transistors, which transistors are like miniature circuits, right? Well, they are circuits. They're like miniature switches that turn on and off based on an input and an output, or two inputs. So those are actually implemented in hardware. But yeah, you'd have to do, are they the same? You'd have to do a negation of the XOR, which I think we could do, right? So XOR is, I think, the hat, a little caret. And then I think we could do a, is or is a bar,
Yeah,
a single
one of
bar.
them instead of the two.
What?
It's just one of them instead of the two.
Yep, just one of them instead of the two. I don't know how to do a, let's see. Operator is not defined for ints. Oh, I'd have to look up. I don't remember it. Let's see. Negate. Oh, it's okay. Bitwise, it's. Maybe I have to put it in here so I can negate it. There we go. Yeah, so you could do the XOR and then you could negate that. Yeah, so XOR is this little caret thing. And this is negation, or flip all the bits. So. All right. Any other questions? Just yawns. I mean, It's a Wednesday, so. All right, so this is a decision of the 2 faculty who teach the class, and I'm okay with it. So we're actually going to, for right now, skip chapter 4, and we're going to go to chapter 5. Don't worry, chapter 4 will not be neglected or demonized, right? But we're going to skip to chapter 5 for a minute, because one of the things that we feel that is important is learning how to use methods, right? You guys have already written one method. We're going to write more methods. And we're just going to, you've always written a method, right? And the one method you've always written is this public static void main. Now we can write our own methods if we want. Oh, my code disappeared. So we're going to write a method, right? It's not going to do anything spectacular. But by default, right, there's going to be a certain set of things that you're going to have to do in order to write a method. So we won't really talk about it in this class. You guys will talk about it in object-oriented. But there are differences between public methods, and we have this other notion called private methods. So we're not going to write any private methods this year. There's also a difference between static methods and non-static methods. So in this class, we're only going to write static methods. So every time you start a method, you're going to use the words public and static in this class. And it is very bad practice to do this after this class. So it's okay. I'll survive telling you to write everything public static. When you get into objects, right, you will write only one thing static in general, but that's okay. And static just means that we have one copy of it. When we get into objects, if you think about having a set of books, right, each book is different. And when you talk about objects, then you have methods that would operate on all books. And anyway, so you're always going to put public and static. And then the next thing that comes is what's called the return type. So that means when you call this method, what does it give you back? Now, if we look in our main method, it gives us back nothing, right? It has this keyword called void. But let's suppose that we're going to have a method that returns an int, or it could return a float, or it could return a double, right? So you pick a type. So we got ints, floats, doubles, booleans, strings, right? All sorts of things. So let's just make a method that has that. And then the next thing that we need, so we need public, right? The scope of it, is it public or not? Static, is it static or not? Return type, and then we get to pick a name. So we can call it anything we want. So I'm just going to call it get int. Now you can't use reserved words, so anything that's purple, right? You can't use any of the types. Right, you can't use a method that starts with a number, right, or hashtag, right? You can add numbers, I think, right, and it's okay with that. So once we say that, now, if you look, we have these little curly brackets that say that my class called methods, this public class called methods, right, starts here and it ends down here. Now, when you write a method, it needs to be inside of that. So it has to be in between the beginning curly bracket and the ending curly bracket. And as you can see, when I highlighted one, it shows me where the bottom one is, so that I know where it is. Now, each method, if you look at this one, right, it has a starting point and an ending point. A starting curly bracket and an ending curly bracket, right? So they all have to be separate. I have so many students who would like put a new method inside of another method. You can't do that, right? Each method has to be inside of the class, but it can't be inside of some other method. And then we have parentheses, right? So you notice we had parentheses up here, and then you guys always had to either type or have that PSVM type out for you, string array args, right? So we add the little curly brackets, and then we're going to put in arguments. So we'll talk about those possibly in a minute. Now this is complaining because I said that this method returned an int, and did I return an int? We don't know how to return anything. But no, I did not return an int. So let me just return a static int, right? So this int is the same. Hitchhiker's Guide to the Galaxy, right? 42. So that means that this method always returns something. Now, so this method isn't doing anything interesting, but we can make methods that do things that are interesting. So I'll just do an example here and then we'll talk about it. So let's talk about this one. So in this one, I have a method called add. Add is going to take one integer called a in this method and another integer called b in this method. And then it's going to add them together. And then the return statement says, this is what I'm going to return when I'm done. Right, so now it has done the adding for me. Okay? Now I can call that method. Oh, I want to keep my code from. It's in my buffer there. I don't want to get rid of it. So inside of my main, I can call this add method. Now, I'm going to call these different things because, I kid you not, every semester students get confused by this. Int x equals 10, y equals 20. So, the name of the variable that I use when I call the method is not the same as the name of the variable inside of the method. So if we look here, I'm calling add on x and y, but when I get into my method, those names are changed, right? I've changed it to a and b. And you can think of it as, okay, when I see the variable x, when it calls add, it's just going to replace x with the number 10. So the value of a inside of here is going to be 10. And for b, it's going to be 20, right? So we're just replacing those. And all the time students will be, well, I called it a outside, so I need to call it a inside of here. No, you can call them completely different things. But when you're inside the method, a has the value of 10, b has the value of 20. Outside of my method, x has the value of 10, y has the value of 20. So what they are is they are copies, right? So I copy that number inside of there. So in my method, if I say a is equal to 18, and I go ahead and print off, let's see. Let's print off all our variables here. So right, so I haven't changed their values. Right? 10 plus 20 is equal to 30. Well, yeah, that makes sense. But inside of here, right, I assigned a to 18. Well, that had no effect, right? Because I'm overriding the copy, right? So if I sat there and an example that I often use, I don't think I have any paper. Oh, I might have paper. Well, I got some waste of space called business cards. Right? So I got a crummy business card here. Right? And the way that I think of it is if I have Trenton over there, he's going to be my method. He's going to be called add, right? And I write on it, A is equal to 10, B is equal to 20, and I give it to him and I say, okay, do what's in this method and return to me something. Right? So he's going to follow the method. He's going to make a variable called result. He's going to write down its value, right? And on my piece of paper that I had, okay, x is 10, y is 20. Trenton's doing some math. You're gonna give me a result. And my pen, because my pens, I don't give my pen away. Right? And he forgot to like mark off that A is now 18 on it, right? So A says 18, B says 20, and result is 30, but all I cared about was the result. So I got the 30 back, and I took it with my X and Y, and I filled it in and printed it off, right? So he was operating on a copy of it. So sometimes students will be like, yeah, I'll just set those variables inside of this add method. Well, that doesn't work, right? Because they're just copies. So you might say, well, why do we have these things called methods? So the reason we have methods is we can take a bunch of work and we can throw it into a method, and then from our main, right, we don't have to worry about all of that work, right? We just call the method and it does that stuff for us. So it's a way of taking a bunch of work and breaking it into pieces where we can comprehend it. So when I was working, and there was a general rule of thumb that said, if your method doesn't fit on a screen, and I have bigger screens than this, right? So a screen is maybe 40 or 50 lines of code, right? If it doesn't fit on one screen, in general, that means that you need to make more methods out of it, right? It's not always true, right? I had some places where I would have, right, case statements that would go on for 100 lines, right? But in general, right, if it's that big, then maybe there are pieces that you can pull out and throw into methods. And the benefit of having it fit on one screen is you can look at all the code at once. And you can look at the whole thing and be able to comprehend it. And if it's longer than that, then you're like, well, I may be able to understand this, but after a while it gets hard. So that's why we have methods. So you might say, well, what's something that I could do that would maybe like simplify my life? So one of the things that we'll probably work on is getting input by using a method. So we've had our scanner, right? You guys call it keyboard. I'm going to call it, let's see, Fred, because that's fun. Okay, so I have my scanner. Well, I might have a method that goes ahead and prints off a prompt and then reads an input from the user. So we'll make a, right, what are my keywords that I need here? Public, static. I'm going to make a method that is going to give me an integer. What do I need next? Int, right? I'll call it get or done, get int. Okay, so I want to be able to read from the scanner. So let me call my scanner. Oh, I'll call it keyboard, right? That's a nice name for it. Well, let's print off a prompt saying something, right? And then how do I get something from the keyboard? I can't even type. Keyboard dot next something. Okay. Next int, right? What do I have to do with that? Yeah. So, so what I generally use, and it always is easiest for me to remember, is I use the word result as a variable that is going to be returned. Because if you're going through your code, you might have temporary variables. It's just easiest to say, okay, result is the thing that I'm going to return at the end. So you don't have to call it result. You can call it anything you want, right? They're variables. You can call it Fred, Ted, Bill, Bob, right? Foobar, anything you want, right? So I read that result, and then I go ahead and how do I give it back to the other method? Return. Okay? Now it's going to stop complaining at me. All right, perfect. All right, so now in my main, you might say, well, we really haven't saved that much. And that's true. We haven't yet, right? So maybe I decide that x is going to be the result of get int. Well, in my main, okay, now that getting of an integer, right, is one line. Before, it would have had to have been 2. Now, when we get to errors, right, and we're going to throw these reading of this until somebody answers something legitimate, right, then all of a sudden these 3 lines become 7 or 8. So now I can take 7 or 8 lines and compress it to 1, right? And remember, right, my scanner is called Fred here, but right, it just gets renamed to keyboard inside of this method. And again, well, we gave it a keyboard, but now maybe we want to have them say enter X and enter Y, right? We change our prompt. So right now our prompt really isn't configured, right? It says get an int, and that's not very helpful. So maybe we add, what could we add to this? That's another thing we could give it. Don't be shy, nobody's gonna laugh at you. It's all good. This is a safe place. If you're wrong, it's okay. What do you think we could add to it? Anybody? Andrew, you want to take a guess? Let's say I didn't want to always have it say enter an int. What did I what was it? What was there that I just deleted? A string, right? So we could add a string. Let's call it prompt. So now I can print off my prompt, right? Well, how many arguments? So these things are called arguments, right? So here I have 2 arguments, and when I call it, I've only given it 1 argument. So I need to add another one. And I could in here say enter X, right? So I go ahead and get an integer, and I change my prompt to say enter X, because that's, right, to the user, that's what they care about, right? They want to have X. And then maybe, all of a sudden now, I can save those lines and say enter Y. Right, so now my assignment, again, has become 1 line instead of the 2 that I had, right, where I had to print off a prompt. Right, and you end up doing that over and over again, right? Print a prompt, read an int, print a prompt, read an int, print a prompt, read a float, right? So now when I run my code, okay, X is 10, Y is 60, right? Hey, I just built a calculator. I actually made a program for my kids that would print off 2 numbers, right, random numbers between 0 and 10, and then have him enter the right number, and then it would say if he got it right or not, right, which is basically like that, right? It just does math. Okay? Now, if you have a method that doesn't do anything, like maybe it just prints off something, well then, the return type, we have this special type called void, which means nothing. So if you define a method as returning void or nothing, then you don't have a return statement inside of your method. And sometimes that's useful for like printing off things. Like if you have a bunch of results and you wanted to print them off, right? You could have a void method that takes maybe a couple arguments and goes ahead and prints them off for you. Okay? Questions?
Is there any way in a method, if you want to specifically keep something in it, but you don't want everything, like it reassigns it, you kept saying, is there any way to keep something in there, like a final or?
Is there any way to keep something?
without it being reassigned.
Yes. But we don't get that until you get to objects, right? So technically you can make an object and you can return the object and then give it that. So it's, we really don't get into that a lot, but you can create objects that you pass in that have fields, and you can modify the fields inside of that object. And so you get a copy of the reference to the object when you pass it in, and so then you can change them. But we really don't get into that inside of this class. So for what we have, right, we can return very simple things. That's a good question. And sometimes it's real pain. And then when you take the C class, you're going to learn about these things called pointers, and you're really going to hate them, but you got to learn them. So, sorry. John will teach you that, and then I'll just beat it into your head. So, pointers are in Java, we have these things that just got automatically created, and we don't have to worry about how what we call memory is managed, but in the real world, somebody's got to manage that. And so we talk about that in C, which is a low-level programming language. Anyway, I put on my instructor hat. Had to tell you things you don't need to know. All right. Other questions? No? Okay. So, Chapter 5, go ahead and read that. You should be able to read that by Friday. All right, so it talks about lots of the things we talked about. It defines some of those that we discussed. So if you were a little confused on what I talked about, it's okay, right? It'll all be all right. Right? Because we'll learn about it in the chapter. So reading the chapter will help you understand these concepts. And we will keep using methods, right? So that's why we're introducing it now, because we're going to use these over and over and over again.